IAAC is running since 2000, in which experts from a variety of different disciplines are invited to discuss their work. And this year we are glad to actually be present with a hybrid format. We are coming back to our lecture series with some talks that they are taking place in person at our facilities in Barcelona, combined with some, as the one of today, that will be held online. So today we have the pleasure to be joined online by Benjamin Bratton. He's connected with us from Los Angeles. Hello, Benjamin. Good to have you here. He will be giving the opening lecture of our fall series. And I'm certain that most of you that know Benjamin Bratton, you know that his talk will not just be a mere presentation of his work. It is certain that his talk will shake much of the stereotypes upon which our minds are operating. So get ready for a critical, sometimes out of our comfort zone, but definitely a constructive and enlightening talk and discussion. So thank you, Benjamin, for joining us today. Just a few words for you or about Benjamin. Operating in the merge of philosophy, architecture, computer science, and geopolitics, Benjamin Bratton is a professor of visual arts at the University of California. He's program director of the Terraforming program at the Strelka Institute, as well as a visiting professor at the IAAC in Los Angeles and then NYU in Shanghai. Benjamin is the author of several books, including the well-known Stack on Software and Sovereignty, a book revealing a new geopolitical theory for the age of global computation and for the age of algorithmic governance. He's also the author of the newly published book, The Revenge of the Real, Politics for a Post-Pandemic World, that calls for a positive biopolitics, describing COVID-19 pandemic as a crisis of political capacity, and of course, as a crisis of political imagination. A couple of months ago, we had a conversation with Benjamin, since he's also contributing to our forthcoming learning series, IAAC Bit Journal. And I have to say that the coherency and the clarity with which he manages to explain the complexity of some of our most contemporary or most, let's say, biggest risks of our contemporary society is a huge necessity. This clarity, this coherence is a huge necessity in today's trend of oversimplification. Today, Benjamin Bratton will share some of the work developed at the Terraforming program, revealing new perspectives on the implications of digital technologies to what counts as urbanism. Interested in new kinds of systems and ways of life emerging from synthetic intelligence in cities, and he will go deep into understanding what synthetic intelligence is. Benjamin will help us dive deep into unique possibilities of producing novelty in urban evolution through different forms of intelligence that operate in a variety of global human or even sometimes non-human inhabited landscapes. So no more to add from my side, just a warning, put your seatbelts on. We're gonna go through some turbulence moments. Thank you, Benjamin, for joining us today, and we are really looking forward to the discussion.
Thank you, Reddy. Thanks very much for the very kind introduction, and I'll do my best to live up to the billing. I'm going to share my screen here real quick, and we can get started. All right, there we go. Hope everyone can see this. So welcome, first of all, and thank you for joining today for the discussion. As already mentioned, I wanted to talk with you a little bit about some research that we've been doing in the Terraforming program at Strelka Institute in Moscow, but more specifically, talk about the way in which this question of artificial intelligence at urban scale is thought about in the program, kind of the approach that we take to it, that may, frankly, lead in directions other than those that we have eventuated into projects. And so in that sense, it's also a kind of invitation. And one of the things that I just want to sort of say up front is that the question of AI at urban scale that we're working with, I think, as you'll see, is quite different than the kind of the more typical smart cities kind of discourse, but it's also one that takes AI not so much as a kind of, not necessarily as a kind of, what do we say, sort of brain in a petri dish, as a kind of artificial human mind that we can judge as it being variously successful or unsuccessful to the extent to which it is able to mimic or even replace forms of human thought and cognition, but rather that what's interesting about it is that it's not necessarily human-like, and that its most interesting capacities may be ones that operate not in replacement to humans, but rather in a kind of coevolution, augmentation, and what we call the synthetic, which is what I'll be talking about. We'll be talking about a little bit today. So first of all, let me introduce a little bit about the context in which some of this thinking is taking place. The Terraforming program is the second of a second 3-year design research think tank, which I've directed at the Strelka Institute. And it takes on a thesis that holds that's about not the terraforming of Mars or the moon in order to make those viable for Earth-like life, but indeed the comprehensive project to ensure that Earth remains capable of supporting Earth-like life, and the realization that in itself is not only that the predicament itself is the result of a terraforming process, but that the response to that predicament is also itself a kind of terraforming process. That is, as Frederick Jameson put it, the glory of the Anthropocene has been to show that we really can change the world. Now it would be intelligent to terraform it, as a quote from this as well. And so on the first hand, one that is this first understanding that what we call the Anthropocene, you could call it whatever you like, all good, lots of good names for this situation, has been a kind of headless, planless terraforming initiative, whether it was meant to be or not, and that we are living in the midst of this terraforming right now. The implication then is that in order to result in a more viable situation, that process will require more foresight, reason, rationality, equity, and so forth. So as we summarize it, the terraforming is the comprehensive project to fundamentally transform Earth's cities, technologies, and ecosystems. And I might also add, more increasingly in our work, governing systems, to ensure that the planet will be capable of supporting Earth-like life, as said. And as I'll talk a little bit more about, just scratch the surface a bit, these 3 A's of artificiality, astronomy, and automation form the basis of that alternative planetarity. And I'll talk more about this question today of artificiality and what we might mean by that in this particular context. For those who are interested, there's a short book that I wrote in July of 2019, which seems like a lifetime ago, in the before times, before the pandemic, that is available for free as an EPUB download from the website. And so if you go to just the terraforming, all one word, .strelka.com, or any of your other favorite file sharing sites for that matter, you can download a copy of this, and this will give you a little bit more of a sense of the research program as we've developed it there together. And I should also say that our admissions for the 3rd year the cycle are open till November 9th. And so you may want to consider or recommend application for those of you as well. Okay, so this is a little bit around this work. Now, let me talk very quickly about where the research comes from. Each year, we have a cohort of 30 researchers who we've chosen, who we are accepted into the program. They're a mix of various different disciplines. They are most of them, plurality of them have some kind of architecture, urbanism, design background, but they're also philosophers, filmmakers, science fiction writers. We've had nuclear physicists, and we're able to we sort of break them into smaller research teams towards the end, and they develop original design research projects based upon the curriculum that we provide them in advance, where they are doing seminars and workshops and lectures with a lot of the big thinkers of the day. And you can, again, look at our website to learn about all of that. And so, again, what I want to talk a little bit about today is how this question of AI at urban scale is dealt with in our particular program. So a starting point for our way of approaching this is that the question of what do we mean by artificial intelligence in the first place is not clear. And certainly it's not clear what AI is necessarily for. Another way of thinking about this is the project that I run at NYU Shanghai was mentioned. A visiting professor there is directing a Center for AI and Culture on study for AI and culture. And one of the things that we're looking at there is the different ways in which notions of artificiality as such and intelligence per se in the difference between Chinese and, let's say simplistically, between Chinese and Western historical notions, connotations of these words, change not only the way in which we might think about what AI is, but indeed, in fact, what AI is for. And so on the one hand, there's the contingency of this word might be defined by, and the contingency of the technology might be defined by the kind of cultural epistemology that is brought to bear on the question, but also more particularly, what it's quite clear to us is that the uses to which AI is put today, if you think of the list of top 10 things AI is used for today, we sort of reject the idea that this is essentially what AI is. There are ways in which, for example, I think a lot of the AI critical discourse and AI ethics discourse becomes, in a way, has looked at the things, and I think their work is very valuable, but has looked at the things that AI is put to do, purposes to which it's put today, and they make claims either directly or indirectly that this is essentially what AI is. And so we move from a world in which it's not algorithms of oppression, but algorithms are oppression. And this is a kind of approach that we reject, because we see that the bigger issues around AI are yet to even be determined or discovered in the first place. And so we're interested in the sort of longer term issues. Second, we assume that in its present form, AI is used for both smart and stupid things, quite clearly. And it's not always so clear which is which. Sometimes one seems like one in the short term, turns out to be other in the long term. But that, as I say, its ultimate purposes may be largely undiscovered. And so the question of that in discovery is part of our interest. As I said, there's an interest not to confuse confuse implementation for ontology. That the way in which what AI is used for is not necessarily what AI is. And the way to ensure that AI is used for something else is to not accept the claim that what it is used for is in fact what it is, because that forecloses all other possibilities. And then instead of rotating a little bit into my topic for today, we also assume that in the natural intelligence, animal intelligence, human intelligence, so forth, took billions of years to evolve over time. It's accelerated extraordinarily quickly in the last tens of thousands of years, since what's called the cognitive revolution, particularly in Homo sapiens. But this took a long-term cycle. And so an evolutionary perspective on the emergence of machine intelligence, it took billions of years for animal intelligence to appear. There's arguably forms of vegetal intelligence and other kinds of things in this as well. But now we have inorganic matter, rocks, metals are assembled in such a way that when you run electrical current through them, they perform feats that could be recognizably intelligent in some way. We should assume then that there is, in a way, a kind of longer term evolutionary trajectory or trajectories for the development of machine intelligence, and that instead of seeing machine intelligence entirely, measuring it entirely in terms of it versus other technologies, we should also see it in the longer term arc of the evolution of intelligence more generally. So what are some of the implications of that? Well, one is that we shouldn't necessarily think of AI as an analog or mirror of human intelligence. In many ways, it may be, but in ways that might be surprising to us, and that may teach us a lot about what human intelligence is. So what I mean by that is this: there are ways in which there's ways in which humans think, and then there are ways in which humans think that humans think. We think that we think in ways that is not how we actually think. And so there's two ways in which you could, and Reza Nagarstani has a lovely piece on this. There's two ways in which we could think about developing AI in the image of human thought. One is that AI, that through the accumulation of aggregates of neural networks, artificial neural networks and other kinds of things, that there is a kind of analogic process to the ways in which brains and central nervous systems form intensifications of thought process through different kinds of methods and techniques, and that there's a way in which at a hardware level, let's say, that we find analogies from. That's fine. But there are also ways in which I say that we believe that we think in ways that we don't actually think. There's, the idea that we have discrete thoughts, discrete memories, that you yourself are a singular subjectivity, as opposed to a complex of different smaller cortexes that experience other kinds of notions of memory. That is, once you get down to the neuroscience, it gets very strange, and we don't think about our thinking is that we've got two hemispheres of our brain, each doing independent processes within a kind of, a bus port in between them, but that's the reality. So what I would want to, in essence, caution against is the idea of building AI in this image of the illusion of how we think. That we have an illusion of thinking in a certain way, and if we build AI that matches this illusion, we are not building AI in the image of human thought. We're building AI in the image of a phantom. I have a picture of Alan Turing here. So one of the other, I think, important points for our approach is an understanding that the philosophy of AI, that AI has evolved in relationship to the philosophy of AI in ways that are perhaps unique for complex technologies, that the philosophy of AI has developed different forms, different kinds of thought experiments. Turing's famous test, for example, Searle's Chinese room, various versions of the Chinese brain experiment, so forth and so on, that have directly influenced the engineering, that have directly influenced the kind of technology that gets developed, which then in turn influences the philosophy. And so unlike, for example, bridge building or automotive design, the philosophy of AI has an important role in developing what it is, and it should continue to do so. But now, to Turing, about my point, as you assume well aware, in an early series as late 1940s, 1950, he proposes a kind of test, a variation on the popular parlor game called the imitation game, in which two hidden contestants, player A and player B, try to convince the third that they are a woman. And they answer responses to leading questions to try to figure out how this works. So in a sense, one of the players is trying to convince the man is trying to convince the third player that they're a woman. The woman is trying to convince the third player that they are a man pretending to be a woman. So indeed, perhaps the first player is trying to pretend to be a woman, pretending to be a man, and so forth and so on. And the third person is trying to figure out who's who. And so Turing proposes, well, what if we had a machine for place player A? So a strict reading of the text would say it's not just a computer trying to pretend to be a human, it's a computer trying to pretend to be a woman. But what he suggests, which has implications for sure, one of the other things, but the way in which he proposes this test is not to say that unless the computer can pass, it is not intelligent. That would be what he's proposing is saying, if it can pass, then we have to say there's some kind of intelligence going on there. In other words, he offers this as a sufficient condition of intelligence, not a necessary condition of intelligence. When it becomes a necessary condition of intelligence, that is, unless the computer can perform thinking the way that we think, then it is excluded from being intelligence. This is not what we intended, but this is in fact, in a certain sense, become part of the way in which the popular culture of AI, and unfortunately in some ways the direction of the commercial development AI has tended. And so unlike in the real world, here's the Voight-Kampff empathy test from Blade Runner based on the Turing test. Instead of the real world is one in which perhaps instead of it being a kind of either or situation where either there's a human or a machine on behind the door number one, this is actually a kind of false dichotomy. The machine intelligence that's behind door number one is never simply human or non-human. It's always a kind of mixture, that behind the machine intelligence is always the agency of a kind of human intelligence, but indeed behind human intelligence is always the agency of different kinds of distributed machine intelligence. And that's just the way it is. And so what we would want to think about then is this kind of amalgamation and a kind of counter modeling between multiple kinds of intelligence rather than a strict classification system that says this one is this and this one is that. Not because that would be more ideal, not only because that would be more perhaps productive or ideal, but also because it's just more realistic. It's just empirically more accurate. But one of the implications of that bigger picture is that it will recognize that intelligence and indeed knowledge more generally is always distributed among multiple positions and multiple forms of life that are both in some ways similar and dissimilar to one another. And so no single neuroanatomical disposition has a privileged monopoly on what it means to think intelligently. That doesn't mean that human sapience is the same as how a plant thinks and that it's all the same. It's not all the same. Sapience is different than sentience, but it doesn't mean that sapience is exclusively the privilege of apes like us. What it means is that general intelligence, more broadly, is not duty bound to any particular species or phylum. And the ability of an organism, however primitive, to map its own surroundings, particularly in relation to friend, food, and foe dynamics, is primordial. And the ways in which it maps abstraction more generally is part of what it means to think, to have cognition at any kind of at any kind of scale. And so this implies then, to a certain extent, that that is a kind of pattern recognition and deduction that is built into this process, or as part of what this process is. The process of looking and testing and tasting is not separate from what thinking is. It's part of what thinking is. And so as today's AI are augmented by various kinds of sensing technologies, machine cognition, vision, and so forth, as different machine intelligence sense the world in particular ways, and abstract their own forms of embodied intelligence thereby, we can see forms of different forms of inorganic intelligence emerging, not just through algorithmic processing, but indeed through the production of sensory data through machine methods. So once more, among this, that sort of more materialist view of what intelligence is distributed in the world more broadly, it also then clearly comes to focus and a kind of intensification in very particular kinds of matter, and the sapient brain tissue of higher primates such as ourselves is not the same as everything else, but it is sense that it itself is part of this material, is part of this flux, a part of the conditions of assemblage by which certain forms of matter come to assemble themselves so that they're able to achieve certain feats of intelligence. And this particular form of matter has achieved, obviously, extraordinary forms of intelligence, unlike other forms, but it is nevertheless one possible assemblage. All right. What I now want to do then is to turn to a little bit of a discussion of what we mean by the artificial and what that might imply for our question here. Well, one way of thinking of the artificial has to do with these are called Thunderstones. They were called Thunderstones. What they are ancient stone axes that were discovered, these particular ones mostly in Europe. And they look kind of just like rocks, but they have this strange chips on them that have a kind of regularity to them that if you're a trained archaeologist, you can differentiate a stone axe from just a rock that you find on the ground. And they were called Thunderstones because it used to be thought that when lightning hits the ground, that it kind of produces these strange regular patterns in the rocks. But it was later to indicate that these regular patterns are caused by chipping away the rocks to make them into basic tools. What is it that the archaeologist sees that allows them to deduce that this is not just a rock? They are seeing anomalous regularity in the object that allows it to deduce that this is artificial. If I show you this image of a forest in Japan, you can immediately tell what part of the forest is artificial and what part of the forest, in terms of where the trees are planted, and what part of the forest grew on its own, because of the anomalous regularity in the pattern of the trees that's growing there. And so one way to think of the artificial has to do with the kind of, it has been designed. And we can tell it has been designed because there is this irregular, anomalous regularity in this way as well. So one way to think about artificial intelligence might have to do with simply deducing the kind of, the anomalous regularity in its ability to do pattern recognition. And that's fine. And there's a whole way of thinking about a kind of design and artificiality that is more generally worthwhile. The way in which we've been thinking about it here more recently is actually in a distinction between the artificial and the synthetic, which we sometimes conflate. And this is derived from the work of Herbert Simon, a book from 1968 called Sciences of the Artificial. And in this book, Simon makes this distinction between the artificial and the synthetic. Roughly speaking, for Simon, the artificial is a counterfeit, a fake. And so the example he gives is of a glass diamond, or a piece of glass that is cut. It's not a diamond, it's a piece of glass that is cut so it looks like a diamond. And so you could wear it in jewelry and it looks kind of like a diamond, but in fact, at a molecular level, it's just glass. That's an artificial diamond. The synthetic, however, would refer to something like a lab-grown diamond that is molecularly identical to a diamond you'd pull out of a mine, but it was made. That's a synthetic diamond. And so you have this now very interesting distinction then between the artificial and the synthetic. And you see where I'm going with this. What that means is then a distinction between artificial intelligence and synthetic intelligence. Artificial intelligence would be something that looks intelligent, seems like it's intelligent, but actually isn't. Synthetic intelligence would be something that genuinely is intelligent, whether it looks like it or not, but at some fundamental level, it genuinely is. And you see the importance here of how it looks to us and how we see ourselves in it is in essence demoted as a priority for this as well. So let me talk about one of the examples of things that we've been looking at, more particularly example, which is artificial languages, or what are called artificial languages. So we could call them NLP, and so synthetic languages. And so I'm sure some of you are familiar with these technologies of late. Things like GPT-3 have brought NLP, or natural language processing, into the mainstream. You probably use your translation apps on your phone, which are all NLP based, that get much better every year. But there's also a kind of history of artificial languages that would include things like Esperanto or Bahasa Indonesia, the development of languages that are deliberately and artificially constructed in order to have a particular kind of purpose to them. But the point I want to make has to do with this artificial to synthetic distinguish when it comes to language, and the way language might identify its distinction within for us. One of the sort of famous example of early NLP was a project from 1966 called Eliza by Joseph Wiesenbaum. And Eliza was a very early chatbot. It was a really simple script. Basically, you type in something and it will sort of parse the grammar and sentence structure of whatever you typed in, and it will send and ask you back a question. And sometimes it will put in a word that you said. And it's just a few lines of code. And all it is doing, again, is just that, taking the sentence structure, reconstructing it, and asking it back to you in the form of a question. It has no understanding of what you're saying at all. It's an illusion. But what Wiesenbaum was sort of surprised at is that people in his lab would sit there with this thing for hours and hours on end, pouring their heart out to this script, and telling them about their relationship with their mother and why they, their trouble they're having with their children and all the rest of this stuff, to this like few lines of code that's just asking them questions back to themselves one way or another. This seems like intelligence, but it's not. It's an artificial language. Now, that's a little bit, and so one of the things that might be different then is some of the newer, larger natural language processors like GPT-3 or the successors to this. I'm right now, I'm writing a piece with Blaise Aware-Iarkos, who from Google Research, who is one of the people who is involved with their development of their large NLP models. They're sort of what will be their GPT-4, thinking about this as well. And so some of the ways in which, other than Turing tests, you can tell some of the differences between the artificial and synthetic intelligence has to do with ability to pass what's called Winograd schema. That is, you have to actually understand the context of the word in the sentence to know what the sentence means, right? And so the trophy doesn't fit into the brown suitcase because it's too large. Is the suitcase too large, or is the trophy too large? Well, if to a human, it's obvious the trophy's too large to fit into the suitcase. But if you're a computer that's just parsing those words, and this is like, you have no idea. You don't know what a trophy is. You don't know how big suitcases are. And so it's a complete mystery. And so what one of the differences, you might say, the measurable differences between some of the older and newer abilities is NLP systems, is their ability to do much better with Winograd schema kind of tests. So this is a conversation with one of Google's newer, a little bit, it's not quite not public yet, internal bots called Mina, which is really good at Turing test stuff. And I've had conversations with it, trying to test this around in terms of even asking it about Winograd schema and those kinds of things. And it's really, really good. It even makes jokes. It can do all kinds of things. It's very good at understanding the kind of context of structure here as well. And so I'm not saying that this thing works just like human language, or this thing is as smart as humans or something like that. What I'm suggesting is we're getting close enough with NLP systems that it's hard to say that there's nothing intelligent happening here whatsoever. I think there is. It's just not something we really have good models for understanding. Another example of that is I visited Sony's AI Lab in Tokyo a couple of years ago with our Strelka researchers when we were doing visits to Tokyo. And this is a still shot from a talk they did for us. Those words at the bottom there, Wabata Mo Tulubi Da Heketi, this is a language that they had devised to teach one robot how to teach another robot how to do something. In this case, take one of those yellow things and stick it on top of the box. And what had happened is that in a matter of days, that language, in the cyclical evolution, in a matter of days, the language had evolved so quickly that the people running Lab had no idea what these robots were saying to one another. They couldn't translate it back, but it still seemed to work. Like they would still say, okay, tell this other one to put 2 pylons on top of the thing. And it would say something, and the other one would go do that thing. And so it seemed to have a kind of still some function, but it was a different kind of language. And so there's something to this also that I think is very interesting. I want to just sort of bookmark, and that is in the development, the extent to which, here's where I'm going with this, to the extent to which human intelligence is in many ways linguistic and well as embodied, but linguistic is obviously a huge part of it. And to the extent to which one of the important areas of research of AI is natural language processing, it stands to reason that this would be a place where we should look for actual genuine epistemological breakthroughs in some regard, but also that it's not just about machines learning how to mimic humans, which is very interesting and perhaps very useful, but also the ways in which language will evolve once it becomes more a machinic phenomenon. That I don't mean just mean C++ and those kinds of artificial language. I mean languages that are generally in protocols and vocabularies that are spoken by machines will be another vector for the development of language more generally. So some of the issues here that with language that in NLPs more generally that are part of the questions is for natural language, we have what are called comprehension and competency without model. That is, you can, a 3-year-old, let's say a 5-year-old can say all kinds of complicated things. It knows the difference about suitcases and trophies. It can say all kinds of complicated things. It can take basic vocabulary and invent complete new concepts with it, but it has no idea of how it's doing it. You can't ask a 5-year-old, how do you know what you know? It's a comprehension and competency without an internal model. With natural language processing, in a way, the model that it has, the n-grams, the models that have language, is in fact, that is the competency. There's no distinction between the two. The question, though, is does it have any comprehension of either of these? And in many cases, it probably doesn't, or if it does, it's a different kind of comprehension. What the problem is that the way in which we sort of tend to look at NLPs is that if it has a high degree of competency, we assume that it must have comprehension. That is, if my Translate app is really good at translating between English and Spanish, I assume it must understand what it's saying. High degree of competency, we presume high degree of comprehension, but that's an illusion because that's not the way it really works. That is to say, it's like one of the things we do is there's a tendency to confuse competency for comprehension when dealing with NLP systems. And it's not clear how we would even define comprehension in relationship to this for both artificial or natural languages. That is there ways in which once you learn grammar and once you learn sentence structure and you learn these formal properties of language, does that change how you think? Does it change how you write? And it probably does, but it's not the same. This is probably kind of a different order kind of question. Okay. So some of the things that Blaise and I have been writing about in terms of the future of NLP, as you probably know, there's been a lot of controversy of late around natural language processing models. The Timnit Gebru has left Google under difficult circumstances, to say the least. Is exemplary of this. I think part of what we're looking at this is coming at it from a somewhat different angle. And that is, if you're looking at NLP as a question of, is the high cost, the research cost, processing costs, and rather worth it for these trivial applications? Maybe not. But if you think of NLP from this bigger perspective of the development of machine intelligence that is capable of operating complex linguistic models with which we are able to communicate, that may ultimately in time show us more about not only what language is, but indeed how we think. Because we see thinking and language happening in a different way. We see our own version in contrast, we understand more of what it means to think in the human way. That is, and that it is a disclosure of thought to itself, potentially. And we argue that that's definitely worth a high cost. Of all the things that AI is for, the disclosure of thought to itself is really the long-term project there. This is connected a little bit with what I have Stanislaw Lem here. You'll notice my background is the ship of Solaris. What he calls epistemological technologies, that is, technologies that actually that are tools with which we are able to think about thinking in some fundamental kind of way. A couple other kind of points here as well, just on this topic, I'll quickly sort of move on here, is that in the discussion between energy and carbon trade-offs, there's a lot of emphasis on how much this kind of core research costs in terms of carbon and energy. It's nothing compared to what our culture, quote unquote, costs. I mean, all of the work in natural language processing in terms of its carbon and energy costs, I will argue, pales in comparison to, sports or other kinds of things that we may argue are less trivial. And so I think this is a conversation that should be had. And so in terms of the trade-off, TikTok or things. So I think in terms of these trade-offs, I think the question of what is this really for is important. So one of the other controversies around this is also the relative, the prioritization of large or small models. Large models like GPT-3 or some of the other ones take a lot of energy and a lot of research to train, and they're basically trained on like the whole internet. And as anyone who's spent more than 10 minutes on the internet knows, there's a lot of crazy shit on the internet. And so it's trained on that just as much as it's trained on everything else. And so you get a lot of weird things in there that are rude or worse, for sure. The small models had the advantage of being relatively highly curated. That is, they don't necessarily have, you can take out all the bad words, so to speak. And but the problem with this also in some extent is that if you're training lots and lots and lots of small models, you can end up using much more energy and by indirectly carbon in training multiple small artisanal models for different kinds of purposes. Plus, there's also the question a little bit of the use of natural language models that are controlled by a kind of council of wise people who might decide what language should be, what language should be, and how it should think and how it would be said. There may be really good reasons for this, and particularly if you're trying to train a model for a specific purpose, particular way of seeing things and talking. There may be other ways in which that becomes a nightmare, in the sense to which the crazy, messy, natural evolution of language is now curtailed into this this sort of frozen moment. Now, one of the other things that we sort of like thought experiments that comes from this, having to do with the machine development of language, has what's called the Internet of Natural Language Processing things. So if you're merging NLP and IoT together, you would get something like this. And so in this case, what you've got are robots that speak a artificial language. They don't actually talk to each other in any direct kind of way. They don't talk to each other in any language that we could possibly understand. But what if they did? What if you used English, for example, as the language that the machines use to talk to each other? Well, there's advantages to this, because in a certain sense that like all of these chips, all of the chips that are built into there already have some NLP capacity already built into them. That instead of having every new year, there's another protocol and competitive protocols, and this platform has that, uses this protocol, and that platform uses that. If you use a natural language as the generic protocol for how machines would talk to one another, their talking to them would be more legible, it would be more understandable, and it would sort of instantly kind of work together. Now, of course, you could use Chinese or Spanish or whatever. This isn't sort of the point, but using NLP as the basis for the machine language itself is a super interesting area of possibility. One of the other things that I've sort of pushed them to sort of work on, this particular group a little bit more, has to do with the development of models of in this case of dying languages. That is, you're aware that, you know, each year and each day there are dialects and languages that are going extinct, and with them a kind of ontology goes extinct as well. Well, it's not a way to sort of prevent this, but if you, with few shot or one shot modeling techniques, if you're able to produce models of those languages, you can produce a kind of ontology seed bank that would allow at some point in the future those languages to have another afterlife, in the same way in which English may end up having an afterlife as it becomes a machine language. These dying languages would at least exist in some kind of way that they could be taught or understood later on in some sort of way as well. So I've talked to you a little bit about these. The BERT is the Google model here, GPT-3 and 4 and the rest of them. These are what are called foundational models. That is, unlike the small models, they are meant to be kind of infrastructural models. You train them once, they have their, they have their sort of larger capacity, and then a bit like a power plant, you plug lots of things into them and they become generally useful for lots of different purposes. And there's been a lot of discussion and to some extent controversy around the role of foundational models more generally. This now widely read piece by basically everyone in the Stanford Stanford AI group co-wrote together about the future and dangers of foundational models in this regard. I recommend that. It's an interesting paper to read for anyone who's sort of interested in this kind of dynamic, for sure. One of the sort of the key points from this as well is also that comes that everyone wants to work on the models. Nobody works on the data, but the problem is, like, what makes the models useful is the veracity of the data, and so there's a lot of issues up here as well. Okay. I want to then sort of move on to try to accelerate this. We have a little bit of time for a conversation by showing you a couple projects from our program. One is called Deep Face, F-A-S-E, and it is looking at the evolution. Now, there's link between artificial natural intelligence in relationship to the evolution of the face. And what I'm showing you here is the full video in like super fast forward mode, just so you can get a little bit of a taster, but you should go to our website and you'll get all of them together. So the word intelligence is used to describe a lot of different things, some of which might be deeply interrelated, others that are quite different. It's used sometimes as a synonym for sentience, and that is the ability to sentience, which is the neurological ability to form a model of the external world, and sometimes as a synonym for sapience, that is the ability to form actionable models about those actionable models of the world. Only very recently, in many ways, it's become possible to think about the sentient sapience dynamic in more evolutionary terms, that is to see it as an effect of particular evolutionary adaptations. Some intelligence as an evolutionary adaptation, some of which took place tens of thousands of years ago, some billions and millions of years ago. So what this project is interested in is how the anatomical convergence of sensory organs, eyes, ears, nose, tongue, etc., bundled close to one another and close to the mass of neurons that we call the brain, is integral to this process. That is how encephalization, the evolution of the head, became for animals coupled with enfacialization, the evolutionary appearance of the face. So in ways that should be both familiar, if also uncanny in some respects, social intelligence among animals, perhaps especially primates, and among those, perhaps especially humans, developed through a complexification of face-to-face communication, meeting the gaze of the other, posing, hiding, wearing masks, all in ways that turn out to be inextricable from the more recent evolution of sapience. Sapience is social, and social is facial, intensely, if not exclusively. So the question that this project poses then is, will it be so forever? What is the future of faciality in relationship to other forms of intelligence? If human social intelligence, that is, if human social intelligence is intensely facial in its evolution, and if that social intelligence has terraformed agency itself, then in what ways can we say that faciality itself has terraforming agency? And if so, what comes next? What is the potential uncoupling of face and intelligence? Now that we're developing forms of intelligence that in a way don't need face in the same way. And these are the questions that kind of animate this project. And through it, we see several kinds of faces. The faces we see in mirrors, the faces we see on screens, the faces we see in clouds, the faces that are seen and recognized by forms of machine intelligence that have no face, or at least no face other than those we insist drawing on them to make ourselves feel more comfortable. So will creatures with faces force faces onto everything so that they can feel seen? Or are we approximating something like peak face? So one of the other ideas, one of the other sort of key concepts that we're sort of working with here, and I realize I'm running short on time, so I'm going to try to compress some of this. We have a little bit of time for more time for conversation. In relationship to these issues of climate change, and I'm going to have to just go real quick with this, or have to do with the idea, the concept that climate change itself, the impact of planetary scale computation on climate change and what its role might be, needs to be based on the context that climate change itself is, the idea of it is an epistemological accomplishment of planetary scale computation. Without the vast planetary sensing and modeling and calculation infrastructure, the idea of climate change, the regularity of the principle of taking all these data points and finding the larger pattern in them is impossible. And so to the extent to which the notion of climate change and its implications, coming with it the implications of what we recognize as an Anthropocene or any of its other nominal variations, and the extent to which that is a challenge to key assumptions about the temporality of history. I'm thinking of Dipesh Chakrabarty's recent work, which argues that history must now be understood not only in terms of social history in the Walter Benjamin sense, but also of below this, a biological history, and below this, a geological history. That's an epistemological sort of shift, an intellectual shift that comes from Anthropocene, comes from the understanding of climate change. But the understanding of climate change itself comes from the organization of planetary scale computation for the purposes of climate science. And so not only is climate change itself an epistemological accomplishment in planetary scale computation, but indeed all those indirect philosophical understandings of the implications of the Anthropocene of climate change are indirect accomplishments or indirect effects of planetary scale computation. No planetary scale computation, no Anthropocene theory. Let us, I want to go very quickly through, on this, I'm going to skip this sort of point because I wanted to show you this sort of last project, and then we'll go for discussion. So I have to show a picture of the Earth. This is all talks have to have a picture of the Earth in them. It's part of the rule of doing talks. But I want you to think about this image a little bit differently. Instead of thinking about the famous blue marble image of Earth taken from Apollo 17, think about this instead as the blue marble movie that portrayed, if it was in motion, it was like this super fast forward movie that portrayed the whole 4.5 billion year career of the planet on some kind of absolute super fast forward so we could actually watch it. What would we see? We would see volcanoes and storms and continents break apart and realign, primordial oceans, the appearance of biological life eventually after the great oxygenation event, and eventually the emergence of an atmosphere to intubate even more life. At the very last moments of this movie, though, you would see something rather unusual. You would see the sprouting of a cloud of satellites and the wrapping of the land and seas and wires with wires made of metal and glass. You would see the sudden appearance of an intricate artificial planetarity crust, a planetary crust, if you like, one that is capable of tremendous feats of communication and calculation that have enabled planetary self-awareness and indeed a kind of planetary sapience. So it is the evolution of this crust that is the basis of planetary scale computation, which is the basis of our understanding of climate change, which is the basis of our understanding of Anthropocene, which is the basis to the challenge of temporality of history that comes through this. It's the emergence of a kind of sensory organ and a kind of cognitive layer. It's not thinking on its own. It allows us to think through it. We are one of the ways in which the planet thinks. Matter is assembled in particular forms in the shape of our brains. And over millions of years, those brains have evolved to consider things like how old the planet is. But other forms of sensing and cognition, such as this planetary crust, have also evolved. And with these two together, the epistemological accomplishments related to climate change emerge. Now, let me then talk more specifically on that. Then this is an example of synthetic intelligence. But let me give one that's a bit more specific, and then that'll be my last project to show you. Synthetic intelligence, then, remember back to the Simon point of this difference between artificial and synthetic. Again, we argue that the various ideologies around artificial intelligence are hobbled by the ways in which we assume that they must be human-like in appearance in order to produce any kind of viable intelligence. And we argue that that's just, and sometimes they are, like with NLP models to some extent, but in other ways they're sort of not. But let me tell you another example of synthetic intelligence, of genuine synthetic intelligence, which you might be aware, but may not. The other connotation of synthetic intelligence might be then the synthesis of human and machine intelligence in pursuit of insights or creativity that would be impossible for either to achieve on their own. A now famous example of this, I think, occurred in the now infamous Go match some years ago between Lee Sedol and AlphaGo, which was in 2016. Famously, then the AI's move, I think in the second game, was move 37. All of a sudden, in the middle of this match, this human versus AI death match, the AI puts the stone in this very weird, unlikely place on the game board. A place that and immediately Sedol he looks at this and he's totally shocked. The announcers are shocked. They're like, oh my God, the AI is broken. It did this crazy, stupid thing. This is so embarrassing for DeepMind. But then Sedol is staring at the board a little bit more and he goes white and he has to get up and leave and like throw water in his face because he realizes, oh my God, it's doing something I've never seen before. And indeed, as the game progressed, it turned out to be the linchpin move that turned the entire game for the AI. And it was a move that was not recognizable to any of the Go experts. In other words, it had been trained by humans through learning lots of games, but it had come up with something novel. This was significant. More significant, however, is what happens next. In the next game, Sedol's move 78 was equally unexpected, equally creative. If the first move, it was also something weird and never seen before. If the first move proved that AlphaGo was in some ways not just smart in the narrow sense of being able to generate, algorithmically crunch possibilities, but actually capable of creating some kind of novelty. The second move proved that in response to that novelty, and Sedol said this, the humans saw the game differently, and so produced a brilliant move that also never could have happened otherwise if it had not seen the move in the previous game. The human saw something it never saw before. It saw the game differently. This is a synthesis of kinds of intelligence. This is a glimpse, I hope, of what general sapience might look like. So let me share with you then one project from our program last year that deals with this very specifically, called Sites of the Synthetic. So And it deals with this example quite clearly. And again, this is in fast forward mode. You can watch it all on our website. So what this project is looking at, this is by Lyra, Nicole, and Joel Fear, Nicole Fitzgerald, Lyra Shinkarova. Instead of thinking of synthetic intelligence as a kind of quasi-anthropomorphic it, or worse, a he or a she, kind of apophenic figuration of AI, the focus instead should be on the landscape itself. And like, what are the framing conditions that make synthesis possible? The game is one of them, but it's not the only one. Intelligence is this, as it is not only is only disclosed as it is possible to be expressed through a particular medium or a particular site of expression. So moving beyond the avatar model of intelligence, in which various figures, human figures, machine figures, otherwise, are the subject of certain kind of analysis, we would instead articulate a figuration, as they put it, of synthetic intelligence through the specification of the site. This specification unfolds through lots of different elements and areas of design. And this is obviously where urbanism comes in rather directly. So it's guided by two questions, this project in particular. How might a landscape of possible intelligences take form? And how might we reorient ourselves accordingly? How might stages be set for the framing and condition of moments of synthesis? There's never been a more pressing moment, I think, for this. So as the technological capacities for AI mature into their potential, the human is decentered from a certain position of privilege in some ways, new modes of intelligibility become much more important in this kind of regard. I'm going to then, I've got a number of things I wanted to sort of show you here, but I'm going to skip through and end with this so that we have time for our discussion. The most critical relationship then between planetarity, what we want to call it, the kind of planet that we are artificially composing, the anthropogenic reality in which we find ourselves, and the implications of climate change for this. Again, something that is made clear to us through planetary scale computation. And what it has revealed to us is so that, again, the computation not only is understood as a tool with which the planet is artificially composed, is also the epistemological mechanism between the planet itself is revealed to us as something that has been composed in this way, that climate change is this implication. All of this depends on the position of intelligence from which any such intervention might take place and how that position might comprehend the situation of its own agency. This is far more difficult than some would have us believe, because it is to be born into a kind of unpayable debt. The decisive paradox for general sapience is the dual recognition that first, its existence, our sapience, our intelligence, is extremely rare and extremely fragile, vulnerable to various threats of extinction in the near and long term. And second, that the ecological and indeed political and human consequences of its historical emergence, of the emergence of intelligence per se, has been a chief driver of the conditions that establish this very same precarity. This approach to questions cannot then avoid the correspondence between, on the one hand, honing our intelligence, our sapience, through machinations of war and strategic violence, and the emergence of machine intelligence that is dependent upon, for example, the provisions of material extraction, military applications, and all of its ecological and social devastations. The emergence of intelligence cannot escape the violence of its appearance. Both modes of intelligence, though, are also, in a way, modes of planetarity. Both are positions from which reason exercises its agency, for better and for worse. Both are tied to what we might recognize as our most inspired aspirations. But if planetary intelligence is to survive, if there is to be a future, if planetary intelligence is to survive the consequences of its own appearance, in the short term and in the long term, it must reform this trajectory or risk its extinction and disappearance. This historical moment may seem long, but it is actually very fleeting, and is defined by this paradoxical challenge that I've outlined. how can we recognize, how can the ongoing emergence of planetary intelligence comprehend its own evolution and the astronomical preciousness of sapience, and simultaneously recognize itself in the reflection of the violence from which it emerged and against which it struggles for its very survival. It is possible that our privilege, human privilege of a kind of retroactive hindsight, will decide in some final register at the end of the day that this history, the violence of this history and the emergence of intelligence was a worthwhile and perhaps even necessary condition for the ultimate emergence of a planetary intelligence. That a planet which, like ours, has managed to fold some of its matter into thinking assemblages, such as human brains. Even if so, its development and its survival depend on the decisive graduation from these primordial habits. What future, I ask, would make the past worth it? What future would make the past worth it? Perhaps the future of planetary intelligence is now as existentially entwined with a radically different career for composition, for foresight, for order giving, as its advent was from the cascading centuries of pilotless destruction. Taking this new existential condition seriously, I argue, demands a radically different form of philosophy and therefore a different form of city. So thank you very much.
Thank you, Benjamin. A digital clapping would be introduced. Thank you for a very inspiring talk. I am sure there is a lot of different questions from the audience, but I will start just to warm up a bit the ambient. And I mean, you have tackled so many different issues. I wouldn't know where to start, but I have two crucial questions. I will start with one.
Yeah.
And let's see how our audience will also interact. So I am very interested when you're saying that we see the artificial intelligence as a mirror of human intelligence, right? And we are at this moment in history that inorganic matter is capable of forms of cognition. But if we see these forms of cognition as a kind of a repetition of what people do or humans do, or organic matter does, then of course this is in a way preventing from using the tool in a way that produces novelty, right? And then I wonder,
it can. I would say it can. I want to qualify the point. It's not. It's that if that monopolizes this, and that is, if the condition in pursuit of synthetic intelligence is only that which mimics the human, we cut off all kinds of interesting things. At the same time, I do think human intelligence is different than other kinds of intelligence. And so if it then sort of feeds back and we are seeing it, we actually understand how human intelligence works in relationship to it, great. Or if there's specific ways in which human intelligence is a useful model for developing AI, that can be okay. What I'm just saying is it can't be an end in and of itself. Okay, so.
I understand. But let's say that, like, if we do this kind of, like mirroring of our human, let's say, thought, then we're using the tool in a specific way. And that tool that is being used in a specific way, it also produces certain effects in the city, in the way that we interact. And of course, if novelty is not allowed to somehow thrive, then that means that we're not using the tool appropriately. But if we use the tool appropriately, then that might change the way or the model upon which we are used to operate in our societies today. And I wonder what would that mean, not only for our lives, but as a designer and as an urban, let's say, maker, I'm also interested in wondering how this could affect the way that our cities look like, no? Now we have certain intelligence and automation related with monitoring, sensing, creating, different kind of data or digital twins of buildings. But we are always thinking of how humans are seeing or perceiving the urban environment. If we allow this synthetic intelligence to produce novelty, then that means that it will also produce environments that they are not how humans see them or how humans perceive them. And what would that mean for our, urban surfaces or our physical, let's say, interface?
Yeah, great question. So I'll try to go through quickly so we can get to lots of questions. But this is a great question. The use of the term tool, I think we should put in quotes here. Like there's ways in which, like if we like tool to me feels like I have an idea for something I want to have happen, and I use the tool, and therefore the thing happens. An epistemological technology is different. It's one in which I have a model of how the world works. I build this technology because it helps me, because based on my model of how the world works, and I want to find out something. But when I use this tool correctly, or I use this technology correctly, it discloses to me that the world works differently than the model that I had that allowed me to make the technology. A microscope is like that. A telescope historically has been like that, right? It's not just about, oh, I can optically see the moon. It's, oh, we get heliocentrism. And heliocentrism has all these other effects on the way in which society came to organize itself. This Copernican trauma. And so I think that on the one hand, there's the deeper question of AI as a generator of these kinds of Copernican traumas that will on a deeper level have all kinds of implications for how society understands it, where it is and when it is and so forth. Now, at the level of the city, I'll speak more practically in terms of a couple of things that we've looked at with our research. One has to do with a kind of bigger picture and smaller picture. The bigger picture has to do with zoning. Like I think that for the most part, a lot of the logic of modern planning and zoning is based upon a kind of industrial and post-industrial arrangement of manufacturing, light manufacturing, residential, education, entertainment, so forth and so on. Like the categories of aggregate behavior by which you would want to divide up the city are predicated on a certain kind of infrastructure, a certain kind of economy, an economy that's based on a certain kind of technical infrastructure. Clearly, one of the ways in which AI comes to exist in the real world is because it gets blended with objects and becomes something we call automation. Automation can take place in terms of production. It can take place in terms of manufacturing. It can take place in terms of transportation. It can take place in terms of entertainment. It can take place in lots of ways. But if it does, then that shifts the technological basis of the economy. And if the technological base of the economy shifts, then the ways that the categories that which you divide up the economy changes, and therefore the way in which you zone cities would necessarily change as well. And so even at the sort of fundamental that kind of level, I think we'll, over the next 100 years, or sooner, next 20 years, we'll see a lot of changes. The other one I would point to is on the more like even perceptual level. And this is based on some work I did with Casey Rem at SciArc. It was sponsored by Google Artist and Machine Intelligence Program. And one of the things that we were looking at was machine vision in the city. The two sort of ways in which we think about machine vision in the city are either the way I look at the city, like augmented reality, like, okay, so there's a phenomenological subject that's looking out at the city, and there's machine vision that provides an interfacial layer. The other one is sort of surveillance models where like the city is looking at me particularly, and it's tracking me particularly. And so both of these are sort of single, first person singular ways of looking at it. Like either the person is looking out at the city or the city is looking at the first person. But what about the ways in which when the city is looking at the city itself, when the city is not looking at other people, it's looking at itself in some ways. And this was the area of our research. And so we were looking at things like, QR codes, the explosion of QR codes as a kind of invasive species, or kind of the response of the city, a kind of blooming of these weird black flowers in the city in response to the invasive species of the smartphone camera. As a response to it, like, you or I can't decipher a QR code. It's there for machine vision. it's there for machine vision, right? And driverless cars don't see the edge of buildings the way we see the edge of buildings. And what we were looking at were ways in which if more of the cities and city surfaces get designed for purposes of how machines will see them, rather than how humans will see them, we're going to get some really weird building surfaces, ones that are, surfaces that are optimized so that they can be, QR surfaces for augmented reality, or edges of buildings that look very strange to us, but actually allow for driverless cars to have a very clear delineation between the building or the not building. And you can sort of spin out ideas very quickly, and all of a sudden you realize, like, aha, if the surfaces of the city have been designed for the way in which one species looks at them and appreciates them, and light is working with them. But if those surfaces are now being seen and interpreted by machines, which can see and process light and information differently, they will look very different. So that was another thing we kind of looked at. But in terms of the urban, I would say, I think we need to look at it from a lot of different levels. One, at the very fundamental level of where do the buildings go? And what are the zoning level aggregations for how cities are sort of laid out, all the way down to the very, very small scale in terms of what materials are used for to build things out of, when those materials now may have functions quite different than they used to have before.
Sorry, I'm muted. I wouldn't like to have a city full of surfaces that they are only readable by machines, no? Which is why I think that the model of synthetic intelligence that you are presenting is a very sophisticated model, very difficult to break down into understand how it could emerge or how it could be operated. But what is for sure is that if we only focus on the potential of technology, then on the one hand, we're limited because of our human mind. And then on the other hand, we are at the risk of innovating and generating innovations that they could be harmful, and they could be aggressive, and they could be unequal for certain parts of our society. And I wonder how, whereas we can and how we can design this intelligence. What is the role of design?
Yeah. Artificiality. It's artificiality in that sense. Yeah.
Artificiality at the end of the day. So
in the first sense of anomalous regulation. No, that was kind of what I was trying to emphasize a little bit at the end. Like I think that the recognition, it's not, I think you go even deeper than to simply say, wow, this tool could be used for lots of different kinds of things, or there are negative uses of this, or even catastrophic uses, like that in the emergence of machine intelligence. I think if you really want to take it deeper, you realize, like, even in the emergence of natural intelligence, that there has been, like, it's also a mountain of gore upon which this sits. And that's kind of my point. And I think but that has also put us in a position where, on the one hand, we are now capable of recognizing this, but it has also put the ongoing capacity, the ongoing future of intelligence at risk on an existential level. And that's this conundrum. I don't know. I don't have a simple answer to the question, because, I'm really loath to suggest that if we have an AI ethics board who comes up with 10 principles, that everything will be okay. I think that, my approach to I suppose I'm probably more closer to sort of, again, Stanislaw Lem's idea that, humans have this weird ability to intervene in evolution in ways that other forms of intelligence and other creatures don't. But we don't really have control over the outcomes of those interventions. Like, it's like you put think of it like a river. Like, you can put the stick in the river and it will cause, it'll cause a sort of currents and waves to fork after the stick as the river flows through it. But like, what that ends up pushing down the line, we don't really know. Like, I don't know that this kind of thing is as well. I think, and this is why, in a certain sense, my focus has been less upon partially because other people are already doing a lot of attention to this. focusing a little bit less on how do we evaluate these immediate term uses and misuses of the technology for particular sort of ends, and how do we think about at a deeper level what the technology is for, how as an epistemological technology, like thinking about planetary scale computation and the stack. Like there's one version of this that it's planetary scale computation uses a giant advertising and manipulation machine. There's another version of planetary scale computation that is the basis of climate science. And they use a lot of the same hardware to do both of these as well. I would argue that the climate science future for planetary scale computation is the one that we should pursue versus the other one. And I think one of the other things you'll notice there is that's a focus on the planet itself rather than a focus on the individual behavior and individual actions of individual users. Like I think to a certain, there's also my critique of where I push back a little bit against Shoshana Zuboff and the surveillance capitalism thing. It's like, I agree with her completely that the way in which these platforms are used to manipulate individuals is pernicious. I would even go further and to say that the problem is that it's focusing planetary scale computation on individuals in the first place, as if individual humans is the right unit of analysis for how we would model the world. And so her response is individuals must counter weaponize themselves and fortify their individuality against this trespassing. And I'm saying, no, the individuation as the focus for planetary computation is the problem that needs to be solved, not the solution.
I see. Michael Groth, I think Michael has a question. Michael, do you want to jump in, switch on your camera?
Sure. Sorry, I'm just pulling my video up now. Thank you, Benjamin, for this talk. This is super interesting.
Thank you.
I was sort of just curious about the, you brought up that we could potentially learn about human intelligence from modeling synthetic or artificial intelligence. I was curious how you think we would know or how we would compare those models. For example, sort of the robots that develop their own language that you shared to communicate with each other. I don't know, what are the mechanisms by which we can say this is a human mode of intelligence or not, or how does this language compare to our own?
Right, it's a great question. Well, the way I would see it is I think that there's a lot of overlap actually, and there is, increasingly in area of cognitive science between the question of comparing human intelligence to its alternatives in relationship to AI and comparing human intelligence to alternatives in relationship to animal cognition. And so there's been a lot of very super interesting work, as I'm sure you know, around about forms of intelligence, birds, octopus, other kinds of things as well. And one of the things that this shows is that intelligence, there's certain aspects of intelligence that seem to be weirdly generic. Like even though, the last common ancestor that humans and octopus had was way before humans, our ancestors walked out of the ocean. Very different evolutionary fork. Certain forms of there are certain aspects that seem generic between these and certain parts that aren't at all. And that's very interesting. I think, but to answer your question more directly, what we want to sort of see is I think that intelligence and cognition more generally is a wider, deeper, stranger spectrum of phenomenon than our own, certainly than our own as our own individual case, and certainly more than the way in which we kind of perceive our individual case. That is the way humans think that humans think. And so to the extent to which it does become possible to map or compare or contrast or to find commonalities within very different other kinds of intelligence, one of the implications is that it shows us a little bit more of like where we are on the map and what is it about our processes that is similar and that is different, is unique. And like that's that's as fundamental of a pursuit as you can imagine. Now, how do you do this? Well, I think you do lots of different things. And I think it depends on the kind of intelligence you're sort of looking at. In the case of the robot language, there may be, there may be grammatical structures, syntax systems, modes of relationship between vocabulary, other kinds of things that end up working where they end up developing something that may look complex, but is actually reductive, maybe reductive is actually complex. That in that case may be seen as like a very strange example for linguistics to consider. As if if you imagine the movie Arrival based on the Ted Chiang novel, where when they meet the alien intelligence, the first thing they do is they send in the linguists to try to figure out how do they think in relationship to the weird language that they have. And so in a way, we're generating our own aliens in a certain kind of sense. It's not certain that there really is an intelligence there in all cases, like there is with the aliens in Arrival. In some cases, it might just be weird noise. We don't really know. But again, I think this is the sort of, what I'm suggesting is not that there's some magic solution here. What I'm suggesting is like, this is the direction that we should be pushing this research toward. This is the more important direction of questions for us to be considering. If you're thinking about it in relationship to, machine sensing and it's a whole different kind of thing. But I think in many ways, I think this is a fundamental question that is one in which all disciplines have something to say. There's a way in which drawing on anthropology will help us understand what's going on here and will help us understand what anthropology is doing. There's ways in which linguistics will, there's ways in which cognitive science will, literature, all of these ways have something to bear on this kind of question. And so I don't think there's a single methodology. I think there are, like anything worthwhile doing, there's lots of techniques that will bear different kinds of fruit.
Great, thank you.
Sure. And architecture is obvious. It goes without saying is, top of the list.
Hannah or Alex,
not just because it starts with an A.
Do you want to jump in for the next question?
I can go.
I think I have Hannah and Alex. Alex, go ahead.
Thank you, Alex. Thank you, Benjamin. Very, very inspiring presentation. Now, I couldn't help but think, especially in the first part of your lecture, about Noam Chomsky and evolutionary linguistics. So there was this part. I recently watched one of Chomsky's lectures on linguistics.
I'm gonna get seasick, I think.
Sorry. Let me just get sit down.
Okay.
He was discussing this particular topic about voluntary actions and involuntary actions, and how he was actually paraphrasing a scientist. He didn't mention the name, but he was basically paraphrasing him, saying that involuntary actions in language at this moment, being a very, let's say, fairly new field of science, we understand it he used an analogy with that, which I think is quite interesting. He said, we understand it something like we are the puppets, we understand the strings, we understand the puppet, but we have no understanding whatsoever of what the puppeteer thinks. And I can't help but think, if we have no understanding, let's say, of why we act and speak in the way that we speak, and we act in the way that we act, of course there are gaps, all right, and important gaps in the way that we understand humans and language, specifically linguistics. I apologize if it seems that I'm being a bit deprecating here, but isn't there a bit of a kind of a hubris in assuming that we the puppets can create new puppets, even if we do not understand the mind of the puppeteer itself, himself or herself? Do you get the question?
Yeah, but I think quite clearly we can. But I think what the implication of your point is, we don't necessarily then understand ourselves as puppeteers either. if we don't understand, if like if we don't necessarily know what we're making. We have the puppet. It does these kinds of things, and it seems to respond to certain kind of movements. But just like we don't, it's like this infinite refraction puppeteer meme. We don't necessarily know, because we don't know the conditions of our own volition and intentionality in what makes a program work. Like we don't then know the conditions by which this agency or intentionality is reverberating all the way down on these Russian doll levels of puppeteers to the one in front of us. What I'm suggesting, however, is that taking the Chomsky analogy, where we start as the puppet and language is the puppeteer, is that in the making of another puppet, in a way, we put ourselves in the position of the puppeteer and may thereby understand ourselves better in terms of that relationship between puppet and puppeteer in which we already find ourselves. It becomes a model that we can test and play with in one way or another, in one way or another as well. Not because it necessarily is, and again, this is the key point though, not because it is a perfect mirror of us, and therefore is a kind of like a mini brain in a box that we can play with, but because it inevitably isn't. And so it's whatever it is that we would learn would be learning from the difference and the contrast, as much as it would be learning from the similarities and homologies and isomorphs between the two as well. So that's how my first inclination as to how to play with the analogy that you propose.
Fantastic. I mean, that's also my hope, that this kind of field of investigation will allow us to actually fill in the gaps, the major gaps that we have in the field of linguistics and the way that we actually work as humans, and that these two fields will actually begin to inform each other. That for me is the most exciting part in this field of investigation, definitely. So thank you very much again, really.
Yeah, I think there's a lot of very exciting parts, but I agree with the linguistics aspects of this part as well, in the sense to which there's ways in which the controversies over NLP are, they're quite legitimate concerns about implementations and applications of NLP in particular kinds of contexts. At the same time, not instead of, but at the same time, I really would want to argue and defend why NLP has a deeper significance than just these specific applications in terms of weighing its direction and its significance for us. Yeah, and allows us to think about the future of language in a way in which, like, we don't normally ever consider it. Language is kind of a given; it's there. It's like the weather. Like, no one made it. It just kind of is. But now it will inevitably, whether we want to, language will have an artificial future.
Thank you very much.
Hannah, do you want to switch on your camera and ask your question? I think it's going to be the last question. Please go ahead.
Oh, hi, Professor Bratton. Thank you for the talk.
Hi, Hannah, how are you?
Yeah, good. So I asked two questions, but maybe you can just pick one. I think today's talk is really a great addition to what I took as facial cognition as an undergraduate class with Professor Bratton. So maybe the first question, I'll just add one sentence to it. I see the way you frame it, the epistemology seems to be more about viewing the planet, the collective, as the subjects, rather than the way that the axiosomaticization put it, that it still put the individual as the ultimate acting agents, if that makes sense. Do you regard your the way that you frame it works in relations to the Stigler's model of like this organ outside of body? Seems yeah.
Tertiary memory and exosomatic memory, all this kind of thing.
Mm-hmm.
Yeah, I mean, I think that there's relations between it too. I think there's, I think that one of the things that, from that the techniques in time, Stigler, and the way in which we're thinking about this development has to do with a kind of emphatic foregrounding of the relationship between technicity and the emergence and evolution of intelligence, that it's not, which Stiegler, as you know, draws from Leroy-Gourand, but obviously the scientific study of human origins has progressed considerably since Leroy-Gourand was writing a long time ago. But that is in the development of and in the use of technology that the possibility and structure of thought emerges in and of itself, right? And so I think Stiegler is one example of this as well. As you know, his sort of drift and alliance with the sort of Heideggerian world is less interesting to me. You know, there's also Kittler and the ways in which, you know, a kind of mechanisms of inscription come to constitute not just the formation of thought, but even the kind of structures of language with this around this as well. So I guess in my sense, I'm more interested in a certain sense. You say it is more interested in the trans-individual conditions of intelligence, the trans-individual conditions of cognition, than in trying to relocate it in a calibrated phenomenological subject. And I think to some extent, there's ways in which the later Stiegler and many of Stiegler's acolyte students, and where they find the question of around AI, automation, algorithmic intelligence, so forth and so on, much more disturbing. Like I'm almost surprised in a way to the extent to which they, how nervous and negative they are about the emergence of this, that the ways in which it's understood primarily in terms of a kind of alienation, derangement, psychosis, alienation on a kind of fundamental level. I'm a little surprised in a way that it's more difficult. It's more difficult than it should be for the Stieglerians to locate the evolution of machine intelligence in a Stieglerian framework than it should be, quite frankly. And I think to some extent you sort of you locate this, I think, quite well. In that is there's a sort of trying to refocus this back to the condition of a condition of experience, and the condition of the ways in which one lives in the world as a kind of basis of this as well. And so all of his more recent work about what the automatic society is doing to this, and the kind of pharmacological derangement of social media and so forth and so on. A lot of good points there, but I think more generally, I think this fundamental, there should be, I'll put it this way, we're waiting on a Stieglerian to come who would draw from the real implications of the Technics in Time trilogy to develop a Stieglerian perspective on the emergence of AI, not only as an extrasomatic organ, but as us as a kind of tethering structure of this as well. And I don't know that unfortunately, it wasn't going to be Stiegler himself, and it might not be Stiegler's crowd that ends up doing this, but I totally foresee the possibility of such a project.
Thank you so much. That's a lot to think about.
Yeah, nice to see you, Hannah. Hope you're well.
Indeed, a lot to think about. I would like to sum up the session by a warm thanks to Benjamin. I think that that there has been a lot of different perspectives from your side, and a lot of food for thinking on what kind of challenges they are posed by AI, what kind of challenges in relation with how we can expand our view on the existing world's models, what kind of challenges or opportunities we have to expand our symbiotic relationship with other intelligence, not only inorganic ones such as animal or plant or vegetable or microbial intelligence, but also machinic ones. And of course, the challenges or let's say, the understanding of the responsibility of driving the possibilities of these technologies towards innovation and towards paths that they are, ethical and sustainable and inclusive. So in a way, there is a lot, there are a lot of different layers within these challenges posed by AI. And I think that if we manage to go beyond the limits of technology or beyond the limits of what we consider that technology could do, then we will have a possibility to discover new ways of thriving in our urban environment. So thank you, Benjamin, very much. Some last words.
Thank you, everybody. Thanks so much for the invitation. Great to see everyone. And please get in touch if you'd like to continue the conversation, or follow us online and consider following the work of the program or joining us going forward. But thank you so much. I hope to see you all soon in person in Barcelona, and we can do this all again over drinks.
That's a date. Let's do that. Let's meet soon.
Okay, good.
Thank you very much, Benjamin.
Okay,
thank you, everybody. Have a good day or have a good evening.
Bye.